Hi, grade sevens. We're going to talk a little bit today about the differences between simple interest and compound interest, which is our newest concept in this unit. So simple interest is interest on principal only, and it goes through the formula of I equals PRT, which is in my previous video. So this is for a simple interest formula, okay? Compound interest is interest on principal and interest on interest previously earned as well. So together, the two of them together. Compound interest is a really important concept because it's most of the interest in the business world today. So the longer you leave money in a bank account with compound interest, the better it will be because it'll earn interest not only on the amount that you first put in the bank account, but also upon the interest each and every time it's compounded. So it earns more and more and more. It's a good thing. So I gave you a very, very simplistic example of this in this chart just to illustrate what I meant. So $200 invested with a rate of 3% for 2 years. Year one, interest is $6. Year two, interest is $6. Again, using this kind of formula. And the total interest is $12 for the 2 years with simple interest. But compound interest earns interest not only on the principal, but also on the interest from the previous year. So you can see from this illustration here that the total interest is $12.18. Doesn't seem like a big difference as we discussed in class, but as I let you know, the more money you have and the faster it grows in the interest rate and the more times it compounds per year, you're talking a lot more money as the years go by if you leave your money untouched, okay? So we looked at a really, really simplistic example of this that I'm going to walk you through again. So in this case, we're thinking about the formula for compound interest, which is a little more difficult than the formula for simple interest. So here we have the principal, and inside the brackets, we have 1 plus R over 9. R is the interest rate as a decimal, and N is the number of times the interest is compounded per year. And I gave you a little chart that I suggested you write down on a little piece of paper that you keep with you at test time. And I also suggested that you keep this formula with you at test time as well. And this chart tells you how many times per year that would happen if that was the compounding action. So if it was compounded quarterly, it'd be 4 times a year. Compounded semi-annually, 2 times. Weekly, 52 times. Monthly, 12 times. Daily, 365 times. Annually, just once. So we looked at the example of $66,500 compounded annually for 1 year at 12% interest. So we looked at these two. I'm so sorry, I don't think I finished here. The N is the number of times interest is compounded per year. So that N and this N is the same. They don't change. They're always the same. And the T over here is the number of years. So in this case being 1. So let's break this down. A equals $6,500, which is our principal, our initial investment. In the brackets, so it was 1 plus 0.12, which is 12% interest written as a decimal, and over 1, which is the N, which is number of times interest is compounded per year. Outside of our brackets, we have 2 numbers. And the first number represents the N, which is the number of times interest is compounded per year, once, because it's annually, and annually is once. And T, the number of years, 1, because it's for 1 year. So if we do the math, we get 6,500, and we do our brackets first. We want to take care of our brackets first. So we take that 0.12 and we add the 1. Remember, we would divide 0.12 by 1 to get our answer. So it's 1 plus 0.12 divided by 1. And we get the answer of 1.12 to the power of 1. So that's when our handy dandy exponent calculator will come in handy. So if you have a scientific calculator, that's great. If you don't, I gave you this link, calculator.net, exponent calculator. It's really handy to just be able to give you that answer. So if you were looking at 1.12 as your base, you would just enter it here. And this question, because we did 2 in classes 1, but this class question is to the power of 1, and we would have it be a 1.12. If you wanted it to be to the power of 2 for a different example, it would show you 1.2544. And it literally, you can type in any kind and it will tell you the right answer. Okay. So this is a great tool to have, especially when you're going into a test, and it's free. So we're looking at that. Now we want to always remember that with these numbers, we multiply them. That's a little trick that you need to remember. Okay, we don't add them, we multiply them. So that's why we came up with to the power of 1, because 1 times 1 is 1. We don't add them and say it's to the power of 2. Okay. And our final answer, once we did this, was 7,280. Then as a class, we did the example, but we did to the power of 2. And unfortunately, my Miro whiteboard was not working at that point, but we determined that the answer was $8,153.60. So we would only be changing one thing if this was for 2 years. We would changing the ends. So the n here would change to a 2, and then the n here would change to a 2. And it would become 2 times 1 and the 2 down here. And that would be making the calculation different. So I know that this is one is take some practice. I highly suggest you kind of quiz yourself with a bunch of them if you want me to check your work. And of course, you'll have homework on this as well. So we'll go over this again in class next week. Do not worry. But this is definitely a good introduction for you on how to understand compound interest in a more simplistic way. So again, keep your formulas nearby, keep your chart nearby. Thanks, guys, and have a great weekend.